Welcome to the Unique Network series of videos in which we wish to acquaint you with the, well, frankly, unique ecosystem built on a custom-developed blockchain tailored to bring out the best in NFTs. My name is Philip, and I'll be guiding you through the series. There's a lot of ground to cover, but we'll break the story into sections that should make it an interesting journey. We truly hope that you'll be inspired by what we wish to convey and that your interest in further research will be piqued. There is a wealth of information available on our network, whether it be technical documentation, tutorials, or blog posts regarding our plans, goals, accomplishments, and current activities. We will show you just how easy we've made creating and minting of an NFT collection, and we're certain you'll be minting your first one just for the fun of unleashing your own one-of-a-kind set into the blockchain wilderness, even if you've had no previous exposure to the process. We also have an active community channel on Telegram and our Discord server, where you are welcome to join in and take part in the discussions and community activities, as well as get informed of the newest developments. The links should be available in the accompanying section of the page below. Unique Network has successfully auctioned for a slot in the 14th parachain auction in the Polkadot's main relay chain and has previously secured a chain in the Kusama Canary network as well. We'll be touching upon what a test canary and the main networks are and what roles they play in the Polkadot ecosystem later on in the series. This series of presentations is primarily aimed at an audience wishing to learn more about the fundamentals of Unique Network, i.e. its underlying concepts, goals, and utility. We will, however, be visiting the practical aspects of the Unique Network's application suite, because we've made it so easy to get up and running that it will be a treat to give it a try. And as the ubiquitous and universally adored phrase goes, without further ado, let's dive into it. I'm boldly going to presume that you have had previous exposure to blockchain technology and its terms and concepts. If the concepts of a cryptographically signed transaction, a block, and the corresponding hash are new to you, there are some engaging and very informative lectures available that will quickly get you up to speed should you desire to delve deeper into the subject. Use the links in the course notes below to access them. But even if it is all new to you, we'll touch upon the basics along the way. Before we focus in on the NFTs and how they became part of the blockchain technologies, there are certain concepts that are worth revisiting. There are three aspects of a blockchain design that compete with each other in such a manner that they dictate some sort of a design trade-off. Although the existence of a holy grail of blockchains consisting of a perfectly secure, infinitely scalable, and thoroughly decentralized network is a possibility, current solutions all implement some balance of trade-offs of the three. In fact, it is a bane of the current solutions that you can attain any two at the expense of the third. For example, fast networks tend to be centralized, as such being less secure than a decentralized, permissionless one. A decentralized peer-to-peer network might be secure and even fast on a small scale, but it might suffer terribly in both speed and transaction costs when scaled up significantly. There is another factor that impacts the transaction speed. Initially, a blockchain recorded a relatively small block of information that contained a group of simple financial transactions. With the advent of Ethereum, it was possible to embed digital contracts into the block content, and with this came a whole new approach of how to best store, transact, and update blocks. Conversely, the size of the data block increased. All of a sudden, additional computational considerations needed to be taken into account for contract processing, and that almost broke the back of the Ethereum network. Slow verification of transactions and exuberant fees upward of $5,000 for a single transaction became the stuff of nightmares. A possibility of dropped transaction due to either outbidding of nodes or timeouts due to network congestion made the design faults of a network not only visible, but painful, stressful, and soul-crushing in cases where the monies were simply lost. However, digital smart contracts introduced a novel concept and a benefit that would outweigh that risk. A possibility of not only encapsulating in time an agreement between parties, but also including an automated transaction to be carried out on the fulfillment of predetermined conditions. And most importantly, all of this could be carried out in a permissionless manner, meaning not needing a third party to authorize or oversee the contract execution. The automated nature of contract processing, i.e., entering a contract via direct agreement, non-centralized and incorruptible verification of the authenticity of the contractees, and unattended execution upon contract condition fulfillment suddenly opened the eyes of all the participants as to how powerful the idea of decentralized contract execution could be. No bureaucracy, almost instant resolution, no overarching and possibly invasive authority, and no gatekeepers for establishing contracts. This also meant throwing out the intermediaries, the enablers and facilitators that relentlessly suck the wealth out of the system by imposing overvalued fees for exclusivity rights and by monopolizing the market. Because this was a truly groundbreaking paradigm, all the benefits and shortcomings were just becoming apparent in the early adoption phase, and this fear of the new was vocally expressed by those who felt directly threatened, the purveyors of the existing banking and financial services. The momentum of the realization that there might be a way for a denizen of the emerging world to attain utter financial independence from the maws of the greedy cash controllers propelled this new technology relentlessly forward. In any case, it was possible to not only record the exchange of fungible tokens in the blockchain, but to transfer ownership of unique tokenized items, create complex financial transaction models that included royalties, shared ownership, renting of digital assets, and sponsorship models. The advent of this new breed of contracts became known as an NFT, denoting a non-fungible token. So let's rewind a bit and touch upon a crucial concept we just mentioned. The term fungible refers to a token that belongs to a class of interchangeable tokens, much like the coins and bills of a standard currency. Hence, a unique, one-of-a-kind token is a non-fungible token. At this point, it became clear that the current blockchains were painfully under-designed for this new phenomena, and were limping in their efforts to change, update, and adapt their current framework. To make things worse, the blockchain by design resisted these structural changes. Due to the inflexibility of the frameworks, each major change could demand a so-called hard fork, whereby all the tokens of an existing chain would need to be manually relocated to a new version of a blockchain, deeming them possibly worthless otherwise. A dire inconvenience. Thus, the stage was set for an emergence of something new, something better designed to tackle these issues. Enter the Polkadot chain of chains. The Polkadot blockchain was introduced as a novel solution to the issues that had arisen from the evolution of the early blockchains. It was created by one of the co-founders of the Ethereum network, Dr. Gavin Wood, who saw the shortcomings of the existing blockchain solutions and proposed a novel model of operation. His solution was to create a chain of chains that would be the framework and common transport for transactions in the Polkadot blockchain. The purpose of this chain was to be the most efficient solution for providing security and decentralization aspects of the security, scalability, and decentralization triad. The verification and authorization aspects of all transactions in the network were delegated to the chain of chains called the relay chains and sometimes referred to as the Layer 0 network, alluding to its core role. This greatly simplified the next step in the network growth, that being the adoption of specialized blockchains that are specifically designed toward being an optimal solution to a specific goal. With the responsibility for secure transactions being relinquished to Layer 0, the Layer 1 blockchain, or more commonly called the parachain, the developers that were working on it were free to focus their attention to the finer details of what it takes to make an efficient environment for specific use cases. This was, well, no other way to put it but revolutionary. The reason for calling it so was that this provided the solution to the third aspect of the three critical elements, the scalability. Specialized chains provided a practical way to build an optimized consensus network, cutting down on both transaction times, payload size, and processing time. We'll go into more detail what this means when applied practically a bit later on. Before we go into the scalability and decentralization aspects, we'll need to revisit the issue of what is the benefit of a parachain, i.e., in what way is it a more efficient solution in comparison to the Ethereum blockchain. Touted as a benefit, the generality of Ethereum's contracts allowed for any imaginable and practically implementable contract to be written to serve as a mechanism for performing a specific task. It soon became clear that in the course of practically implementing a utility in the blockchain, there are many tasks that are essentially identical. In the beginning, instead of a common, tried and trusted contract, every provider of the smart contract would write their version to handle the task. In this proliferation of contracts, bad players started implementing code in the contracts that would exploit the unwary. Security was compromised by the simple fact that it was not a simple matter for a regular wallet user to determine if the request for approval from a smart contract could lead to damages and loss of assets. The other issue was, why rewrite the code for common operations anew over and over again? In time, this led to creation of contract frameworks, audited code pools, etc. as a way to ensure safe and tested code. The perpetual processing of common code for basic functionality on the other side was consuming a lot of processor power unnecessarily and slowing down the transaction time, making the network slow and inefficient. This was fast becoming a scaling issue. As it was impractical to expand the number of validators dynamically to meet the needs of the network, the simple demand for transaction processing drove the price into sharp spikes with the spikes in demand. The way to circumvent this is actually the core premise of a parachain. A parachain is a specialized blockchain. The way it establishes its specialization is by constructing a limited set of contracts that are written as optimized solutions for specific tasks and built into the core of the blockchain. This allows any application built on such a blockchain to simply reference a precompiled, optimized version of the contract instead of writing it all anew. The contract would be atomically executed on the validator node without the need to send and reinterpret the source code of the contract via the network. The result of this approach leads to use of less processing resources, lower power consumption per smart contract execution, faster execution, greater transaction throughput, and conversely, better scalability. The special cases of smart contracts that implement custom operations are handled by the regular contract processing pipeline. A well-optimized parachain reduces this to a minimum. So we come to the point where we can unambiguously describe and define what the unique network is and what it provides. Unique network provides blockchain solutions via parachains based on the Kusama and Polkadot relay chains that are specifically optimized for the NFT digital asset. The unique network blockchain allows for efficient creation of NFT collections and their management, construction of NFTs with complex properties, sponsoring of minting by the creator, and built-in transaction rate limiting as a means to thwart mint bots, nesting linked relational trees of NFTs, bundling, mixed bundles of fungible and non-fungible tokens, and refungibility, fractional ownership. In this episode, we explore the fundamentals of blockchain technology, the novel ideas and solutions that came about with its evolution through challenges, the basis on which the relay and parachain approach to finding an optimal network solution rests, and why this, combined with an NFT specialized blockchain, seems to be the perfect combination for creating an ideal NFT platform. We will continue exploring these topics in the upcoming videos.